Good morning, ma'am. Myself, T. Kaushik Reddy from CSCB, and my roll number is 229518050. And my today's physics AAT Tech Talk topic is quantum communication for wireless wide area networks. So let's get started. So wireless wide area networks are nothing but 3G or 4G mobile phones. So mobile phones all are the wireless wide area networks which has 4G network or 5G, etc. So what is WAN? WAN, a local area network LAN can span a single building or campus. A metropolitan area network MAN can span a single city. A wide area network WAN can span cities in multiple cities, countries, continents. 1957 ARPA, Advanced Research Projects Agency, project started a military research for a satellite communications, and in 1972, first public of a demonstration of ARPANET introduces networks into our lives of many competing systems created at this time. So, Ethernet and Ethernet were the most popular local areas network technologies have become the most popular form of computer networks. LANs now connect more computers than any other type of network. The fundamental difference between a WAN and a LAN is scalability. WANs can be able to connect as many computers and networks as possible. The most popular example of WAN is the internet. So a WAN is constructed from many switches to which individual computers connect. Additional switches can be added as needed to connect additional sites or additional computers. So here's the history of the internet. In 1960s, there was a great concern that a nuclear strike would render all traditional communications useless. As a result, the US Department Defense funded that ARPANET in the development of decentralized, resilient, and self-configuring communications network. So first, ARPANET net connections. The first ARPANET links were between UCLA and Stanford Research Institute in November 1969. A month later, links to the University of Utah and the UC Santa Barbara. Clean rock standing next to the first inter-message processor IMP at UCLA. So you can see Lane Croc standing next to the first inter-message processor IMP at the UCLA in the given side of the image. Exponential growth of the internet. After widespread commercialization of the internet in 1980s, internet use grew and continues to grow at an exponential rate. So number of internet hosts. So here is the widespread commercial. So growth of the internet from 0 to like 350 or in the years to 1992 to 10. So there was a lot of growth of the internet in the between 1992 and 2004 year. So wide area networks WAN. Switches in WANs. The basic electronic switch used in WAN is called a packet switch because it moves a complete packets from one connection to another. WANs are often built using leased lines. At each end of the leased line, a router connects to the LAN and on no one side and a hub within the WAN on the other. Leased lines can be very expensive instead of using leased lines. WANs can also be built using less costly circuit switching or packet switching methods. So it's a diagram of wide area networks or WAN used to connect to other packet switches, used to connect to computers on the right side and packet switching in between. So LAN, MAN, and WAN, local area networks on the customer premises. Wide area networks connect sites across a region, country, the world. Next, metropolitan area networks connects sites in a single metropolitan area, a city, and suburbs, a type of WAN. LAN, MAN, WAN. So sites within, between, and between. Implementation self, carrier. Ability to choose technology, high, low, low. Who does the work of operation the network? Self, carrier, and carrier. So here is the like sites, implementation, ability to choose technology of LAN, MAN, and WAN. So next, LAN, MANs, and WAN. So the comparison between LAN, MAN, and WAN according to the price, cost per bit transmitted. Therefore, typical speed. Price, LAN has high related to cost, high unpredictable for MAN, and for WAN, highly unpredictable. Next, cost per bit transmitted. LAN, low. And for MAN, it's medium. And for WAN, it's high. Therefore, typical speed. For LAN, it's 100 Mbps to 1 Gbps or more. Next MAN, 10 to 100 Mbps. And for WAN, it's 1 to 50 Mbps. So next, another combination of LAN, MAN, and WAN, that is, can you switch the technology? Can you route technology? For LAN, yes. For MAN, yes. And for WAN, yes. And can use routed technology for LAN, MAN, and WAN, both are yes. Sorry, 3 are yes. Single networks versus internets technology. Can be LAN, WAN. Can be single switched or wireless network? Both for LAN and WAN, it is yes. Can be an internet? Yes. Both for LAN and WAN, it is yes for both of them. The next, components of WAN. Components of what? Side 1. Access LAN, customer premise equipment, and side 2, customer premise equipment across LAN. And the WAN core from where our electricity or something will pass. Next is switched data network standards. Metropolitan area Ethernet. Metropolitan area network, man, city and environs smaller distances than national or international WANs. So lower prices and higher speeds. Speeds of 1 Mbps to 100 Mbps. Detailed learning is needed because all firms are familiar with Ethernet. Carrier can provision or reprovision service speed rapidly, giving flexibility. The only PSTN service growing rapidly. Wide area networking. To connect different sites within an organization. So this is a graph for wide area, nothing but WAN, to different components. Using the internet for wide area networking. The internet is wide area network. Many corporations are beginning to use the internet for some part of the WAN traffic. In the future, the internet is likely to carry most corporate site-to-site traffic and other WAN traffic. Using the internet for wide area networking attractions, the price per bit transmitted is very low because of large economies of scale. All corporate sites, employees, customers, suppliers, and other business partners are connected to the internet. So what are the issues for wide area networking or WAN? The security of traffic flowing over the internet, variable quality of service, and without any guarantees. Virtual WANs. Most companies have multiple WANs, technology components, leased line networks, PSTNs of network types, different types, internet transmission, cellular transmission, different access like technologies, etc. And virtual WANs have another 1 point, which has sub of 2 points. Traditionally, each component has been managed separately. However, traffic between hosts often passes through multiple components. This makes it difficult to manage overall performance and efficiency. Virtual WANs. Virtual WAN software provides overall management of individual WAN components. Virtual WAN software. Leased line network components, PSTN component 1, PSTN component 2, ISP MPL service. Virtual WAN software allows components to be managed as an integrated system. Multiplexing. FDM. Frequency division multiplexing, analog modulated to a fixed frequency band channel. TDM, time division multiplexing, same frequency in alternating time slices. Each channel makes full use of the bandwidth. GSM and DMPS use TDM. CDM, code division multiplex, makes better use of frequency than FDM and TDM. Signals are transmitted on the same frequency and same time, but have unique code to identify itself. CDM may use CDM of course. Next, second generation phone systems. Second generation IS 136, DMPS, GSM, and IS 95 CDMA. Conclusion. So the basic conclusion is nothing but the paper represents the first work to investigate the issue about wireless communication for mobile devices in the quantum domain. This paper proposes a quantum routing mechanics which enables a quantum mobile device to teleport a quantum state to a remote site, even if they do not share EPR pairs mutually in the terms of time. Complexity. The time that quantum routing mechanics takes to teleport a quantum state is independent of the number of routing hopes. From this aspect, the proposed quantum routing mechanism is close to optimum in data transmission time. In addition, in order to establish a quantum communication infrastructure, this paper also presents a network architecture for wireless WAN. The architecture is a scalable and its responding corresponding communication protocol is developed as well. So the virtual WANs are there are many virtual WANs. Like first one is virtual WANs like leased line networks, PSTNs of different types, internet transmission, cellular transmission, different access link technologies, virtual WANs, another traditionally. Each component has been managed separately. However, traffic between hosts often passes through multiple components. This makes it difficult to manage overall performance and efficiency. And virtual WAN often or software provides overall management of the individual WAN components, virtual WAN software. So, multiplexing, FDM, frequency division multiplexing analog modulated to a fixed frequency band channel. TDM, time division multiplexing, same frequency in alternating time slices. Each channel makes full use of the bandwidth GSM, MPS use TDM. CDM, code division multiplexing, makes better use of frequency than FDM and TDM. Signals are transmitted on the same frequency and same time, but have unique code to identify CDM. Use CDM, of course. At last conclusion, this paper returns the first work to investigate the issue about the wireless connection for mobile devices in the quantum domain. This paper proposes a quantum routing mechanism which enables a quantum mobile devices to teleport a quantum state to the remote site, even if they do not share EPRPS mutually. In terms of the time complexity, the time that quantum routing mechanism takes to teleport a quantum state is independent of the number of routing hops. From this aspect, the proposed quantum routine mechanics is close to optimum in data transmission time. In addition, in order to establish a quantum communication infrastructure, this paper also presents the network architecture for a wireless WAN. The architecture is scalable and its corresponding communication protocol is developed as well. So basically, the 3G and 4G wireless wide area networks like 3G, 4G, and nowadays we have 5G. These are the wireless wide area networks, which helps in communicating through long distances through phone or through laptops like Skype calls, WhatsApp, video calls, etc. So thank you. This is my PPT or tech talk on wireless wide area networks. So thank you.